Hi all. Today we are going to see about the topic of VR input devices. That is virtual reality of systems. And this is video number 1, lecture number 4. That is recap. We see about VR input devices such as body, feet, handle, gestures, gaze, and separate devices from interaction technique. The VR system consisting of multiple components, that is content, software, user input modules, and VR simulation loop consisting of system delay causes, that is VR simulation loop, where a system delay causes sickness. And that next is reduce the system delay. To reduce system delay, we have predictive tracking and faster components. From content to user, there will be from user concept modeling program, and from the modeling program we will have a content such as 3D model and textures, and the 3D model textures based upon the translation of CAD data. Translation, that is modeling program from the model, the 3D the content of 3D model tested is 3D model tested based upon a modeling program, and translation data. The translation data is getting from the CAD data. Next, you have software. From the software application programming. From the application programming, you will be given to generate dynamic generator. The dynamic generator generates the rendering process of 3D visual and 3D sounds. And from user input, we have three types. We have three modules. First module consists of input devices. Input devices is based upon gloves, mics, and trackers. Output devices consist of HMD, audio, and haptic devices. Moreover, user consists of actions. The user action consists of speak. User has actions and speaking actions and grabbing action. User action consists of speaking and grabbing options. Next, the types of VR graphics. The type of VR graphics consists of panorama, capture 3D content, and modeling content. Panorama consists of 360 images or videos. This capture 3D consists of scanned objects and spaces. Model content consists of handheld created 3D models and existing 3D assets. That is, in the left side images shows the panorama view. First we will take a panorama view, and we are going to capture 3D content. Next, from 3D content we are going to model the content. This is a typical VR stimulation. We have a tracking input. From user will be have a tracking input. From the tracking input is given to the applications. From the application it goes to the rendering process. From the rendering process you have a display that's nothing but the output. This is a typical VR stimulation. And the user will be doing some sort of tracking process. From the tracking process gives the input, or the tracking input gives to the application. From the application it gives to the rendering process. From the rendering process it gives to the display. That is nothing but output. So the output from the output is again given to the HMD, that is head mounted displays. The user moves heads, scene updates, and display graphics on it. Display graphics when it has been changed. Next, there is called system delay. The system can be kind of tracking delay, application delay, rendering delay, and display delay. This delay has been compensated by the term called synchronization delay. That need to be synchronized system to reduce the delays. This is a VR system. The modern VR system consists of particular triangles, that is primitives. From the primitives we have AI network stimulation. From the AI network stimulation we will be giving to the shadow maps. From the shadow maps we are going to rasterization. From the rasterization we are given to time wrap from time and left distortion. This time wrap distortion based on head tracking devices. Head tracking devices is HDMI synchronization. From the HDMI synchronization is given to display. This head tracking is based upon the time wrap and less distortion and rasterization. From the display which being used to user input and tracking. This user input and tracking is given to AI network stimulation. The scene graph. This scene graph consisting of three like structure for organizing VR graphics. For example, we have VRML, OSG, and XTD. That is three like structure consists of VRML, virtual relative markup language, OSG, and XTD. Hierarchy of node device, the groups, switches, sequences. Next, it can transformations, projection, geometry. This is a hierarchy for nodes that can be defined. Next, states and attributes, that state and determination, materials and texture, lighting and blending. This is an example of scene graph. The scene graph consists of root node. From the root node there are transformations. From the transformation you have geometry, and the transformation, for example, consider this a simple car model at 4 wheels. Only one wheel geometry is object in the scene graph. That is based on movement of the wheel. We have a transformation. This transformation is held into the geometry. From the geometry, it has been mapped into the called root node. Hence, thank you for watching this video. Hence, the remaining will be continued in next video. Thank you for watching this video. Thank you.